Okay, so you have this question here. Ron's on a Ferris wheel of radius 35. It turns counterclockwise at a rate of 1 revolution every 12 seconds. The lowest point is 15 feet above the ground, which we'll call the point 0, 15 on a rectangular coordinate system. To the nearest tenth of a foot, find the x and y coordinates of Ron at t equals 5. If the Ferris wheel starts t equals 0 with Ron at 35 to 50. Okay, so let's draw a Ferris wheel first. Here's the ground. Here's my Ferris wheel. We're told that this point here is 0, 15, and that the radius is equal to 35. So that's 35 feet. So that must tell me that this has coordinates 35, and then my height is 15 plus 35 because I'm up, and so that would be 50. I'm at the top of the Ferris wheel, or he's at the top of the Ferris wheel when let me just give myself more space. Okay, that would be an x coordinate of 0, and then you're at the diameter plus 15 feet high, so that would be 70 plus 15, 85. Okay, this point here is the same height as the one on the right, but the x coordinate should be negative 35. Okay, and then I'm back to the bottom. He's doing a revolution, 1 revolution every 12 seconds, and we're starting, looks like he's starting here. So if this is t equals 0, this must be at t equals 3, this is at t equals 6, this is at t equals 9, and then we're back here at time 12. And so in order to answer this question about his coordinates, we need to model his x and y coordinates separately as functions of time. Okay, so I'm going to just do my x coordinate here first. Time is 12 seconds for both. Okay, we'll start with this one. And so we just need to plot these points where our independent variable here is t. So 0, so he starts at, so time 0, his x coordinate is 35. So he's there. And then he, at time 3, his x coordinate is 0. And then at 6, his x coordinate is negative 35. And then his x coordinate is at 0 at t equals 9, and then it's back up to 12. Okay, and so that looks like a cosine graph with a amplitude of 35. There's no vertical shift and there's no horizontal shift, so I don't need to add anything to the end. I just need the period, and the period is 12, which means my b value, which is 2 pi over b, that means that b is 2 pi over 12, or pi over 6. So pi over 6t. So there's his x coordinate at any time, and we'll plug 5 into that to answer our question. But first, let's do the y as well. So I'm going to draw a different graph. Okay, now at time 0, his y coordinate is 50. At time 3, the y coordinate is 85. At time 6, it's back to 50. At time 9, it's at 15. And at time 12, it's back up to 50. And so this should remind you of a sine graph. And there is a vertical shift, there's no horizontal shift, and the amplitude is 35, so it's not inverted. So it's 35 sine, it has the same period, right? It's doing a repetition, there's no horizontal shift, but there's a vertical shift up 50. All right, and so now So we got our, so the answer to the question is just whatever we get when we plug 5 in to each of those functions. So we'll go do that, and okay, we'll be done. Okay, so again, just make sure you're in radians. So we're doing 35 cosine of pi over 6 times 5. And then we're doing 35 sine of pi over 6 times 5. And then we're going to add 50 to that. So it looks like it's negative 30.3, 67.5. Okay, and I think we wanted to round, what does it say, round to the nearest tenth of a foot. Okay, so there we are.